Today we are starting chapter 5 in our calculus books, and we're going to begin with section 5.1, which is all about estimating finite sums. And so you may be wondering what this has to do with calculus, but as with most of the concepts that we learn, it all begins with a concept and then gets developed into our calculus idea. And so actually today we're going to be using basic geometry and then kind of develop an idea with that will lead to what's known in calculus as the integral. So let's get back to basics. We're beginning with basic geometry, and our task for this entire section, 5.1, is basically finding areas. And so, like for example 1, we're asked to find the area between this curve and the x-axis. And actually that's kind of a big important point, is that the areas we're going to be finding today are going to either be under some curve, like between that curve and the x-axis, or between some sort of set of data, some y values, some points, some ordered pairs, and the x-axis. So that's important that we understand all of our areas are going to be above the x-axis for today. Okay, so in number 1, you can see that they gave us this equation. But in number 2, instead of giving us an equation, they gave us a table of values. And so we need to learn a strategy for both a smooth connected curve as well as disconnected discrete data. So I'm going to go ahead and begin with number 1. And we're being asked to refer to the region R enclosed between the graph of this curve and the x-axis, but not for all x values, which is nice, just between the x values of 0 and 2. It wants us to partition that interval into 4 subintervals, and then show the 4 rectangles that RRAM uses to approximate the area of that region. So you're probably wondering what the heck this is all talking about. Okay, well, RRAM stands for Right Rectangular Approximation Method. Because here's the thing. We have no known formula for this shape formed by this curve in the x-axis. So instead we're going to use some rectangles to approximate the area under that curve, between that curve and the x-axis. And then really quick, before I do that, I just want to show you that it asks you to then repeat that process for MRAM. And so MRAM stands for midpoint rectangular approximation method. And then in this problem it doesn't specify, but in some of the homework problems it does ask you to find LRAM. And so you can probably guess that stands for left rectangular approximation method. Okay, but this particular problem is talking about RRAM. So that is the one that I will work out for you. Okay, so it wants us to refer to this region. And all it gives us is the equation, meaning we need to go ahead and sketch that graph. So we need to remember features of quadratic equations. And one of those features is that the factors turn into the roots, turn into the x-intercepts. So if I set this equal to 0 and solve by factoring, I have basically found my x-intercepts, and I know that there's going to be 2 of them because it's a second degree polynomial. So there are my x-intercepts. I've got one at 0 and 2, which works out nicely because that's also the interval that I'm working with. And so I kind of need to know what's going on in between. And I know the parabola is facing down, so I know it's going to kind of go up like this. So what I would really like to find is the maximum value. We can either use calculus to do that, or we can just find the vertex using algebra, whatever you prefer. And so maybe I'll use the algebra method where we would go negative b over 2a. And in this scenario, b is 2 and a is negative 1. And so we end up getting positive 1 when we divide those numbers. And so that's the x-coordinate. And to find the y-coordinate, I would then just go back and substitute that 1 back into the original equation. And I would get 2 times 1 minus 1 squared And so that would give me 1 for the y value. All right, so there is my region. My region is this stuff in here. Because remember, it's between the curve and the x-axis. So there's our area right there. Okay, but I'm asked to split that area into 4 subintervals. Right now it's kind of split nicely into 2. And I'm going to go ahead and split those in half. And so now I have an interval between 0 and 1/2, a second interval between 1/2 and 1, a third interval between 1 and 1.5, and then another interval between 1.5 and 2. And I'm supposed to use RAM. That means that I'm going to use the right endpoint for each subinterval to determine the height of these rectangles. I'm going to basically draw 4 rectangles, slice this into 4 rectangles, and use that as an approximation of all that area. Okay, so for my first rectangle, I'm going to use 1/2, which is on the right. And I'm going to go up to where it hits the curve, and then that's the height of that first rectangle. Then for the next rectangle, I go over to 1, which is the right endpoint of the second interval, and go all the way up to where it hits the curve, and that's the height of the second rectangle. The third rectangle, I use 1.5. I go up to where it hits the curve, and that's the height of the third rectangle. And then for the fourth rectangle, I use 2, and notice it's right at 0. So the height of my final rectangle is actually 0. And so basically, I'm just going to find the areas of all of these different rectangles and add them up. And so that's what I mean by basic geometry, because the area of a rectangle is just base times height. And so I'm just going to do base times height for the first one, base times height for the second one, base times height for the third one, base times height for the fourth one, and add them up. And so my RAM is going to equal, oh, and then also notice the way that these have been split is so that the bases are the same for all 4 rectangles. So that base is 1/2, that base is 1/2, that base is 1/2, and the final base is 1/2. So that makes it easy. They all have the same base. So it's going to be 1/2 times, and then to find the height, I'd have to plug this x coordinate of 1/2 into this formula for the curve. So to find the height, I'd have to figure out what 2 times 1/2 minus 1/2 squared is. And so this is 1, and then this is 1/4, and so I get 3/4 for the height of the first rectangle, or 0.75. I would do the same thing for the second rectangle, but this time I would plug 1 in here, which I did earlier and got 1. So the base of the second rectangle is 1/2, and the height is 1. And then for the third rectangle, I would use 1.5 as my x value to plug in here. And it turns out that when you do that, you get 0.5 like with the first one. So I have 1/2 times 0.75 again. And then with the fourth rectangle, I would plug 2 in here, and that would get me 0, because 4 minus 4 is 0. And so I'd have 1/2 times 0. So it's base times height plus base times height plus base times height plus base times height, 4 rectangles. And then when you add all of that up, you end up with 1.25 units squared. So that is the RAM. I would like you now to go ahead and try the MRAM and see if you kind of understand the process. And when you do the MRAM, basically what you're going to do, instead of using the 1/2, the 1, the 1.5, and 2, is you're going to use the midpoints to determine the heights. So you're going to use 1/4, and then 3/4, and then 1 and 1/4, and then 1 and 3/4, and then that's how you'll determine those heights. And if you successfully do your MRAM, you should end up with 1.375 units squared. So why don't you go ahead and try that one, and then when you're ready, move on to example 2.